Okay, video 2 right here on lesson 3.1. And let's get right after it. Keep talking about these functions, right? So example 3, is the relation a function? If so, is it one-to-one or not one-to-one? So here are our 4 data pairs, right? XY, 1, 2, XY, 5, 6. Those are all X and Y's. So first of all, let's remember what a function means, right? So a function is where each X goes to only one Y. So you would see X, one arrow going to a Y. It would be not a function. It would be not a function if you see one X going to 2 separate Y's. That's not a function. Now, the idea of one-to-one, a function is one-to-one if no 2 elements of the domain map to the same element of the range. So now what we're talking about here is the following, right? One-to-one. So still, a function is also one-to-one if every X goes to 1 Y, right? It would be not one-to-one if you had 2 separate X's, like an X1 going to a Y and an X2 going to that same Y. It would be a function because each X is going to a Y, but it would not be one-to-one because this Y is not attached to just one X, it's attached to 2. Okay, so there's the idea. All right, so let's take a look at our relation here. So again, we have 4 XY pairs, XY, 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 XY. So I'm going to make an input-output table. Okay, so here's my inputs. These are my X's. Here's my outputs. These are my Y's. In and out. I'm going to put the X's in numerical order. So they are kind of in numerical order. 1, 5, 7, 8. I'm going to put the Y's in numerical order as well. So I'd have -1, then 0, then 2, then 6. Right? So here's my domain on the left, my range on the right. So now let's go ahead and map them, right? So 1 is attached to 2. 5 is attached to 6. 7 is attached to -1. And 8 is attached to 0. And notice, each X goes to exactly 1 Y. This is a function. Notice that no 2 X's go to the same Y. No Y has 2 arrows going to it. This is also one-to-one. There we go. Nice. All right, so again, big talk about functions and one-to-one. All right, next, part B. Is this relation a function? If so, is it one-to-one? So let's take a look here. They already have our mapping, right? So 1 to 17, 2 to 17, 3 to 11, 4 to 10, 5 to 10. Notice that each X, each input only has 1 arrow going from it. So this is a function. Yahoo! But now, if we look, notice that this 17 has 2 arrows going to it. This 10 has 2 arrows going to it. This is not one-to-one. So it's a function, but it's not one-to-one. And for your example, from this mapping, you have a 1 and a 2, 2 separate X values, both going to 17. That's why it's not one-to-one. All right, last but not least here, let's talk about a real-life example. So this is example 4, identify constraints on the domain. So the diagram shows shipping charges as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of this function? So over here in this input-output table, your weight is your input, and the shipping cost is your output, right? So the shipping cost depends on the weight of the object. Now, if you're going to ship something, it has to have some weight, but the weight cannot be negative. So I believe that your domain, okay, or your weight must include values greater than 0. Greater than 0, and that would be in pounds. So in notation, your domain, colon, brace, your domain for x would have to be greater than 0. Okay, and this is very typical for real life problems, right? Typically, we don't have negative numbers involved, so it would just be here. There you go. All right, so that is your lesson here on relations and functions. Best of luck on your practice. Thanks for watching.